Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring solving systems of equations by graphing. Before we do, let's look at a couple of definitions. A system of equations is a set of two or more equations with the same variables. The solution to a system of linear equations is the location where the lines intersect. The solution to a system of equations is expressed as an ordered pair. So when you write your solution, it'll look something like this: x, comma, y. All right. Now, when you graph a system of equations, there's three things that could happen. You could have one solution, no solution, or infinitely many solutions. So let's look at each one of those cases, all right? Now, in our first example, we have an example of a linear system that has one solution because it intersects in one place. Now, that happens in this case because the slopes are different. So my first line had a slope of -1. My second line had a slope of +2. So if your slopes are different, that means the two lines will eventually cross somewhere. So let's write this down. The system will have one solution because the slopes are different. And in this example, that solution is 1, 2, 3, 3, 2. That's the point where they intersect. So one solution occurs when the slopes are different. Now, the other thing that can occur is you'll end up with two parallel lines. And because two parallel lines will never intersect, there will be no solution. Now, let's talk about why there is no solution here. In this case, what I want you to notice is the slopes are the same, but the y-intercepts are different. So when the slopes are the same and the y-intercepts are different, that's going to create parallel lines, which means there are no solution. So let's summarize that. This system will have no solution because the slopes are the same and the y-intercepts are different. Now, the third thing that could happen is that your two lines land directly on top of each other. Now, I know it's hard to see it, but this third graph is one line and then another line right on top of that. When that occurs, every single point on the line continuing to infinitely is a solution. So this system will have infinitely many solutions. And infinitely many solutions occurs when the slopes are the same and the y-intercepts are the same. In other words, everything about the two lines are the same. The two lines, when that happens, the two lines land right on top of each other and you have infinitely many solutions. Now, let's look at this, how this may be tested on a standardized test or a unit test your teacher might give you. In example 1, it says a system of equations is shown. Which of the following is true about this system? A, there's infinitely many solutions. B, the only solution is -8, 5. C, the only solution is 5, -8. Or D, there is no solution. Well, to know which is the correct answer, the first thing I would want to do is get these two equations written in slope-intercept form so that I can examine their slopes and their y-intercepts. So I'm going to take my first equation, x plus y equals -8, and rewrite it in slope-intercept form. So we would subtract the x from both sides, and we would get y equals -8 minus x. So now the y is by itself, and we can identify that our slope is -1, and our y-intercept is -8. All right, now let's look at our second equation. we have 2x plus 2y is equal to 10. So to get it in slope-intercept form, the first thing I want to do is subtract the 2x, and that would give me 2y equals 10 minus 2x. Then divide both sides by 2 to get y equals 5. Here we have negative 2 divided by 2 would be negative 1x, or just negative x. So a slope is negative 1, and our y-intercept is 5. So let's compare the slopes. Here we have a slope of negative 1, and here we have a slope of negative 1. Now let's compare our y-intercepts. Here we have a y-intercept of negative 8. Here we have a y-intercept of 5. So the slopes are the same, but the y-intercepts are different. So let's look back up at our chart. The slopes are the same, but the y-intercepts are different. That means the two lines are parallel, and there would be no solution. I really don't even need to graph these, because if the slopes are the same and the y-intercepts are different, I know they're never going to cross. So there's really no need for me to graph it. All right. Example 2. The function f of x equals negative 4x plus 8 represents the first of two equations in a system of linear equations. The second equation in the system has a different slope than the first equation. Which statement is true about the solution to the system of equations? A, the system has no solutions. B, the system has exactly one solution. C, the system has exactly two solutions. Or D, the system has infinitely many solutions. Now, before we solve this, I'm going to get rid of one answer. Because in a system, the only three things that can happen is you can have one solution, no solution, or infinitely many solutions. So I'm going to get rid of C, which says the system has two solutions. That can never happen in a system of linear equations. So let's go back and read our equation. Our first equation was f of x equals negative 4x plus 8. So we have a slope of negative 4 and a y-intercept of positive 8. Now, our second equation has a different slope than the first equation. Now, there's our clue. It said we had a different slope. So let me go back up here to our chart. In example 1, if the slopes are different, it says the system will have one solution because they're going to intersect in one place. So I'm going to select B. The system has exactly one solution, and I'm going to write because the slopes are different. Example 3. Solve each system by graphing. So in our first, in our system, we have 2x plus y equals negative 4, and negative 3y equals 2x plus 12. So I have two separate lines here. And what I want to do is I want to examine their slopes and their y-intercepts to see, is there even a solution here? So 2x plus y equals negative 4. If we put this in slope-intercept form, we would subtract 2x from both sides, and that would give me y equals negative 4 minus 2x. So I have a slope of negative 2 and a y-intercept of negative 4. All right, now let me change colors here. My second equation is negative 3y equals 2x plus 12. So if I divide everything by negative 3, I would get y equals negative 2/3 x, and 12 divided by negative 3 is negative 4. So my slope is negative 2/3, and my y-intercept is negative 4. Now, when I compare the slopes, notice that they are different. So I know these two lines will intersect in one location. So what we want to do is find the location where they're going to intersect. So let's start with the blue line. let's graph the blue line. The blue line begins, our B is at -4. So 1, 2, 3, 4. And it goes down to right 1, down to right 1. Now let's go the other way. Let's go up and left, up to left, up to left. And I like to fill in, on the first line, I like to fill in the entire grid. And on the second line, I just graph points until I can see where they intersect. Okay, so there's my blue line. Now my second line, I'll call that my red line, starts at -4 and it goes down to right 3, and I'll go up 2 and left 3. Now, if I draw that line in, I think you can see where the two lines are going to intersect. Let me highlight it, because where they intersect is our solution. So this particular solution will be 0, -4. That's where the two lines intersected. All right, let's try another example. We have 2x is equal to 6 minus y. Now, when I'm getting this in slope-intercept form, I like the y to be on the left side. So when I write it down, I'm going to put 6 minus y equals 2x. I didn't change anything about the equation. I just kind of flip-flop the sides here so that the y is on the left side. So now I'll subtract the 6 from both sides. So -y equals 2x minus 6. And then I'll divide everything by -1. So 2 divided by -1 would be -2x. -6 divided by -1 would be +6. So I have a slope of -2 and a y-intercept of 6. All right, now I'll do the second line. We have 5x minus 4y equals 28. Subtract the 5x to get -4y equals 28 minus 5x. Then divide both sides by every term, by -4 to give me -7. And -5 divided by -4 will be +5 over 4x. So our slope is +5 over 4, and our y-intercept is -7. Now let's compare our slopes. Here we have a slope of -2. Here we have a slope of 5/4. So because they're different, I know the two lines will intersect in one place. So let's graph the blue line. It has a beginning point of 6. So 1, 2, 3, 4, 5, 6. Oh, I wanted a pen, not a highlighter. 1, 2, 3, 4, 5, 6. All right, so there's my beginning point, my y-intercept. Now I'm going to go down to right 1. And remember I said on the first line, I like to fill up the entire grid. Okay? Because I don't know where they're going to cross. And the more accurate and straight you draw these lines, the better chance you'll have of seeing where they cross. Now, my second line, the red line, starts at -7. 1, 2, 3, 4, 5, 6, 7. And it has a slope of +5 over 4. So 1, 2, 3, 4, 5. 1, 2, 3. Oh, looky there. I only had to make 2 dots, and I figured out where they crossed. So you don't have to, once you know where they cross, you don't have to draw any more dots. Okay? So their intersection point occurs right here, and that's where your solution would be. So 1, 2, 3, 4, and down 2. So my solution point is going to be 4, -2. That would be the solution to the system. All right. Let's end the lesson with another example of how this concept might be tested on a standardized test or a unit test. So in example 4, it says, which graph best represents the system of equations and its solution? So we have 8x minus 4y equals -16, and 3x plus 15y equals -6. So I'm going to take my first equation, 8x minus 4y equals -16, and I want to get the y by itself. So I'll subtract 8x from both sides, and that will give me negative 4y equals negative 16 minus 8x. Then divide by negative 4, and I get y equals negative 16 divided by negative 4 is positive 4. Here, negative 8 divided by negative 4 is positive 2x. So I have a slope of 2 and a y-intercept of 4. Now, let's see if we can eliminate any bad answers real quick before we do the second line. All right, so a y-intercept of 4. 1, 2, 3. Well, neither of these lines in problem A go through 4, so I know it can't be A. All right, look at B. 1, 2, 3, 4. We do have a line that has a y-intercept of 4, so it might be B. Okay, now let's look at C. 1, 2, 3, 4. Neither line goes through a y-intercept of 4, so let's eliminate C. And D. 1, 2, 3. Oh, my goodness, neither line has a y-intercept of 4. So I don't even have to solve the second equation now. I know that the only possible answer choice is answer choice B. And that concludes today's lesson, Solving Systems of Equations by Graphing.